Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to factor quadratic expressions of the form ax squared plus bx plus c. This standard is covered in Algebra 1, 2, and Pre-Calculus courses. Don't forget there are 4 practice problems at the end of this presentation that we'd like you to try out in order to demonstrate mastery of the contents covered in this tutorial. If you'd like to gain access to our entire playlist, course list, and other valuable resources, take a look at the link in the description below, or you can just visit our website at mathgotserved.com. Alrighty, the instructions for the examples that we're working on is as follows. We have to factor each quadratic completely. Okay, let's go ahead and write that down. To factor each quadratic completely. All right, so let's go ahead and take a look at the first example. So for question number 1, let's say we have the quadratic 3r squared minus 2r minus 8. All right, so as we highlighted in the previous presentation, whenever you're factoring any polynomial expression, the first question you always want to ask yourself is there a GCF that can be pulled out of the original expression? Okay, if you can factor out the GCF, always do that first because it will significantly simplify the factorization process. Okay, so here, is there any GCF that we can pull out? Well, to make it obvious about the possibility of pulling out a GCF or not, we're going to break down each term, okay? So let's break down 3r squared. That gives us 3 times r times r. If we break down 2r, that's 2 times r. And then if we decompose 8, break it down completely, we have 2 times 2 times 2. Okay? So now the question is there a factor or factors that are common in these 3 terms that we have here? And the answer is no, there's no term that's common. Okay, so we're going to multiply everything back together. So we have 3r squared minus 2r minus 8. All right, so we have a quadratic trinomial here. So now our goal is, can we rewrite this in as 4 terms so that we can factor by grouping? Basically, we need to replace this middle term with 2 terms that enables us to factor by grouping. So how can we express this as 4 terms in such a way that we can factor by grouping? In order to do that, we're going to play the X game. Okay, so let's go ahead and play the X game. So to play the X game, it helps us to find 2 numbers that makes this quadratic expression factorable by grouping. We're going to put AC on the top, and then B will go on the bottom. Okay, so since our quadratic is already in standard form, A is the leading coefficient, B is the middle coefficient, and C is the last one. So AC in this problem is going to be negative 24, which is 3 times negative 8, and B is going to be negative 2. Okay? Alrighty, so what 2 numbers multiply to give you negative 24 and add to give you negative 2? So let's go ahead and write down all the pair of integers that multiply to give us 24, and we'll see which one combines to give us 2. Okay? Alright, so 24, what times what gives us 24? 1 times 24 is 24. And then 2 goes into 24 12 times. 3 goes into 24 8 times. 4 goes into 24 6 times. We have a complete loop because 5 doesn't go into 24. Alright, so which pair gives us 2? If you look at the first pair, that gives us 25 or 23, no good. The next one gives us 10 or 8, no good. The next one gives us 11 when you add, or 5 when you subtract, no good. This one gives us 10 when you add, or 2 when you subtract. Voila, this is the combination that we need right here. Okay, so we have 4 and 6. Let's resolve the sign. In order for the product to be negative and the sum negative, the bigger has to be negative. Okay, now since A is not 1, you have to factor by grouping. Okay, so A is not 1. You have to factor by grouping. Remember, in the previous presentation we did, a was 1. So if a is 1, you don't have to factor by grouping. You can just jump to the factored state, but that's not the case here. A is not 1, so we have to factor by grouping, okay? So we're going to have 3r squared. We're going to replace the middle term with these two. So we have plus 4, and then there's an r there, so bring down the r, minus 6. This minus 6, there's an r there, bring down the r. Minus 8. Now, this polynomial we have right here is exactly the same as what we had before. We just wrote it using 4 terms so that we can split it down the center and factor by grouping. Okay, so that's the beauty of the X game. So let's split it down the center. We're now going to proceed to factor by grouping. Okay, so if we decompose the first term, what's that going to give us? We're going to have 3 times r. And if we decompose 4, that's 2 times r. And if we break down 6, that's 2 times 3 times r. And then if you break down 8, that's 2 times 2. Okay? All right, so on the left side of the partition, we're going to factor out the GCF. So what's common on the left side? We have r, and r is common. And that's basically it. Okay? So we're going to factor out r. Remember, when you factor out a term, you divide it out, okay? Same thing, so that's divided out, that's divided out. So you're left with 3r plus 4, okay? And then in the next pair of terms here, notice you have a minus here, so we're going to be bringing down that minus. We're going to be factoring out a minus, okay? So that has a certain effect on what's left. So what's common? We have a minus and a minus. That's common. We also have 2. That's common. So what we're going to do is factor out negative 2. Okay, so we're factoring out a negative 2 and a negative 2. All right, so when you pull out negative 2, guess what happens? Not only do you divide out the 2, you also divide out the negatives, or you take the opposite of the sign. So this 2 gets divided out to 1, and this sign flips to the opposite. This 2 gets divided out to 1, and this sign flips to the opposite. Okay, anytime you factor out a negative, the signs switch. Okay, and then you're left with 3r plus 2 times 2, which is 4. Now, this is where you freeze and check to make sure everything is looking good, and it looks great right now. Why is that? Well, because the quantities in parentheses are identical. Okay? So now what we're going to do is we're going to factor out these two. Quantities are identical, squiggly, squiggly. The quantity 3r plus 4 is identical. So we factor that out. That gives us 3r plus 4. And then we're left with r minus 2. We group those two together in their own little parentheses like that. Okay? So there goes the factored state of question number 1. So you have to remember that multiplication commutes. So you can write it like this, or you can write it as r minus 2 times the quantity 3r plus 4. It makes no difference. They're both the same since multiplication commutes. All right, let's go ahead and take a look at another example. For number 2, let's consider a problem of this nature. For number 2, let's say we have the quadratic binomial 2a squared minus 14a. So the task here is to factor completely. Alrighty, so for question number 2, 2a squared minus 14a, the first question we're going to ask ourselves is there a greatest common factor that can be factored out? In order to answer that question, what we're going to do is we're going to decompose or break down both terms, okay? So let's break down the first term. If we break it down, we have 2 times a minus, if you break down 14, you have 2 times 7 times a. Alrighty? So now we're going to ask ourselves, do we have anything common on the left and to the right side of the minus? All right, so if we look at the left and the right side of this minus right here, there are common factors that we can factor out. We have 2 and a 2 is common, and then we have a and a are common. So what we're going to do is factor out 2 times a, or just 2a, okay? So when you factor out a common factor, in this case the GCF, which is 2a, it's as though you're dividing out by that factor. So we have a scenario where 2 is factored out and divided out, and then a is factored out and divided out. So we are left with quantity a minus 7, and that is the complete factorization of problem number 2. Okay? If you look at the quantity in the parentheses, it is a linear binomial with no common factors. That's the simplest form you can achieve. And then you have this monomial right here. So this is a complete factorization of problem number 2. Alrighty, let's go ahead and take a look at another example, number 3, and then we'll give you some practice problems to try out to demonstrate mastery of this skill right here, okay? So let's say we have the quadratic trinomial 3m squared minus 25m plus 42. All right, so we're going to factor it completely. Okay, so first things first, the first question you always want to ask yourself is there a common factor that can be factored out, a GCF that can be factored out? So to answer that question, we have to break down each term into its prime factor decomposition form. So the first one is 3 times m times m. Second one is 5 times 5 times m. And then for 42, let's use our factor tree. I'm going to do it right here. All right, so since it's even, 2 goes in there. 2 goes in there how many times? 21. 3 goes into 21, because if you add the digits, you get a multiple of 3. 7. Okay, so it's 2 times 3 times 7. Okay, so 2 times 3 times 7. Now, is there a common factor in all 3 terms? So this is term 1, term 2, term 3. Is there a factor that's common? The answer is no. Okay, so we don't have any GCF to extract here. So we're just going to multiply them back together and strategize as to how to factor this, okay? All right, so we have a trinomial. We need an even number of terms so we can factor by grouping. So I need to figure out 2 terms I can replace the middle term with so I can factor by grouping. In order to figure out what those 2 terms are, we're going to play a game, the X game, okay? Or the AC method. We're going to play that right now. AC goes on top, B goes on the bottom, okay? So this is A, the leading coefficient, B is the coefficient of the first degree term, and C is the last one. Okay, so A is 3, B is negative 25, and C is 42. All right, so AC is 3 times 42. 3 times 42 is 120 plus 6, which is 126. And B is negative 25. So the question is, what 2 numbers multiply or add to give you, multiply to give you 126 and add to give you negative 25? So in order to figure that out, let's create our list of factors that multiply to give us 126 and see which one combined to give us the desired sum of negative 25. Okay? All right, so let's do it. We're going to have 126. 1 goes into 126 times. Now there's 2 going to 126, yeah, because it's even. So 2 goes into 12 6 times. 2 goes into 6 3 times. Does 3 go into 126? Well, it certainly does. How do we know? Well, because first of all, we multiplied 3 by 42 to get 126. Or if you add the digits, 1 plus 2 plus 6 is 9, and it's a multiple of 3. Or 9 is divisible by 3, so 3 automatically goes into 126, which is 42 times. How about 4? Divisibility rule for 4, you look at the last 2 digits. Does it form a number that is divisible by 4? Does 4 go into 26? The answer is no. So 4 is not a factor. Okay? And then 5, the last digit is not 5 or 0, so 5 is not a factor. How about 6? 6 looks like a factor. How do we know? Check this out. If you look at the factor tree, we have 2 times 3. 6 is a factor of 42, so 6 has to be a factor of 126. Or if you look at our list of numbers here, we have 2 and 3, so if 2 and 3, both prime goes into the number, then the product of the primes will also be able to go into that number. Alrighty, so 6 goes, how many times? 6 goes into 12. 2 times, 6 goes into 6 once. How about 7? Check this out. There's a 7 here as a factor of 42, so that tells us for sure that 7 goes into 126. How many times? 7 goes into 12 once, remainder 5. 7 goes into 56 8 times. Okay, how about 8? Does 8 go? One of the factors of 8 is 4. Okay? Now, since 4 doesn't go into 126, 8 cannot go because 4 is also a factor of 8. How about 9? Well, it looks like 9 can go because we multiplied 42 by 3 to get 126. There's a 3 as a factor of 42, and we have another 3 here. If you multiply them together, you get 9. All right, so 9 goes into 126 how many times? 9 goes into 12 once, remainder 3. 9 goes into 36 14 times. Okay, 10 doesn't go because this doesn't end up with a 0. 11 doesn't go either because, 11 times 11 is 121. And then the next one is going to be much higher than this. If you add 11 to 121 for the next factor, you go from 121. Add another 11, you have 132. So 126 is in between, is not a factor of 11. All right, and then for 12, 4 goes into 12, and since 4 doesn't go into 126, 4 does not go into 126. That means 12 cannot go here either. All right, and then 13, if you try dividing this by 13, it doesn't work. Ladies and gentlemen, we have a complete list of factors of 126. Now let's inspect and see which pairs give us 25. All right, the first one gives us 127 or 125, no good. The next pair gives us 65 or 61, no good. Next pair gives us 39 or 45, no good. Next pair gives us 27 or 15, no good. The next pair gives us 25, oh, there you go, or 11, 25. Jackpot. We have the pair that we desire, which is 7 and 18. Okay, so we're going to put it right here, 7 and 18. Now, in order for the sum to be negative and the product positive, they both have to have negative signs. That's exactly what we want. Okay, let's go ahead and put it in. So if we put it in, we're now going to have 3m squared minus 7m minus 18m. Now, this is a question that normally comes up, which is, does the order in which you write these two numbers that we got from the x game matter? The answer is no. Okay, if you switch the order, it just reverses the order of the factors in the factored state. Now that we have 4 terms, we can break it down the center and factor by grouping. Okay, all right, let's decompose or break down every single term on the left and the right of our split. On the left side, we have 3 times m minus 7 times m. On the right side of our split, if we break down 18, you have 2 times 3 times 3 times m. And then if you break down 42, we already did that here, is 2 times 3 times 2 times 3 times 7. Okay, so now let's look at the left side of our partition. Do you see a greatest common factor that can be extracted? And the answer is yes. You can factor out an m. Okay, so factor out an m, that's common. So we have an m. If you factor it out, it's as though you're dividing it out, so that's divided out. And we're left with the quantity 3m minus 7. All right, right side of our partition, oh dear, we have a minus in the middle, which means signs are going to start flipping all over the place. So we're factoring out a negative, which means the signs will change, and a GCF. So what's the related associated GCF? Let's see. 2 and 2 is common. 3 and 3, that's the GCF. 2 times 3 is the GCF. Okay, so we're going to factor out 2 times 3, which is 6. Factor out 2 times 3. So when you factor it out, guess what? You divide it out. So 2 is out and 3 is out, and together they multiply to give you what? 6. Okay, but since we took out a minus, this minus is gone, so it becomes a plus. And then this minus, this plus, guess what? It switches to a negative. That's the impact of factoring out a negative. The signs flip. Okay, all right, so now we'll bring down what's left, which is 3m minus 7. So this is where we freeze and do our check. How are we looking so far? We're looking fantastic. Well, why is that? Well, because the quantities in the parentheses are identical. Okay, if that's not the case, then we must have made a mistake somewhere. So now what we're going to do is we're going to factor out these identical quantities, 3m minus 7. Factor them out. Remember, when you factor out a factor, you are dividing by that factor. So the quantity 3m minus 7 gets divided out. And guess what? We are left with m minus 7. Okay, so we group them together in their minus 6, sorry, in its own nice little parentheses. And that's the answer to question number 3. You can write it in this form, 3m minus 7 times quantity m minus 6, or you can reverse the order. Since multiplication commutes, you can also write it as m minus 6 times the quantity 3m minus 7. So there you have it. Okay, so it's now your turn to try out some practice problems. Okay, so these are 4 practice problems we'd like you to do. The task here, as indicated, is we'd like you to factor completely. Okay, so go ahead and pause this video presentation at this time and attack these 4 problems. When you're done, click on the play button, and then we are going to display what the answers are. Alrighty, welcome back. So hopefully you had a chance to try out the problems. These are the solutions. Question number 1. The factored state is 3b plus 2 times b minus 4. For number 2, the factored state is 2n times quantity n plus 8. For number 3, the factored state is 7x minus 9 times x minus 6. And for number 4, the factored state is 2v minus 1 times v minus 8. Okay, so how well did you do with these practice problems? Let us know in the comment section below how well you did. If you have any questions or need any clarifications, just let us know and we'll be more than glad to support you. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial helpful in your studies of quadratics, to give us a like. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel for updates to future uploads. We upload math tutorials to our page on a weekly basis, so do subscribe in order to get notified. And if you have any questions or special requests, as indicated earlier, just place it in the comment section below. Check out the links in the description for access to the entire course list. Other valuable resources can be found at mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.